And hello to everybody. Thanks for joining us, and hope you're enjoying ScratchCon. So my name's Guy Hutchins, and I'm here for the bug hunting session. So we can get started here. We're just a couple minutes delayed here, but we'll hopefully catch up what we're doing here. So I'll jump over to my slides here and get us started. So if we can swap over here. Oh, okay. So yeah, this is going to be a live demonstration of bug hunting. So I've really tried to create the presentation I could do for ScratchCon that has the most likely chance of blowing up in my face. We'll see how it goes, but that's all part of the fun. Bad things happen when you're trying to create stuff. Things don't always go your way. So we'll see if that happens, and we'll find out that it's not really that big a deal, and you can just work through things and find solutions. So that's the real theme of the day here, playing our way through and making things happen. So, like I say, my name is Kai Hutchins. I'm CEO of Massive Learning Corporation, and I'm the author of the, let's get these out earlier, Teacher's Guide to Scratch book series. So a whole lot of information on Scratch. I am fairly familiar with it, and hopefully you are too, but if you're not, this session is all about helping you get the confidence that you might be lacking for now in working with Scratch and making sure you can do whatever you like. So this is all about bug hunting. So bug hunting is something that is unwanted in a program or project. So it can be, you know, something going wrong, something not showing up, something moving the wrong way, a sequence going wrong, whatever it is, something's wrong with your project. That can happen for a whole bunch of different reasons. You could just have made a mistake, typo, you might be overlooking something, you might have forgotten something, you might not understand how something works, you might have an idea that's, you know, totally the opposite of how things actually work. Sometimes it'll even be just an issue with the language that you're programming. It doesn't do a certain thing, or it does it in a weird way, or sometimes, you know, the website's just broken or something like that. So they can happen for any number of reasons. Sometimes, you know, it's because of you, sometimes it's because of someone else or something else. They just happen. And so the really important thing that we should think about is it's unavoidable, right? They can come up because of reasons that you don't even have control over. So bugs are going to happen. Bug hunting is about how we find those problems, fix them, maybe prevent them from happening in the first place, or if we can't do that, just finding a way to work around them. So there's lots of things that we can do, but the main point is we're going to do it. So why bug hunting is important is, of course, bugs will happen. And chances are they'll happen fairly frequently and early and often. So it really is a huge skill to have when you're making any kind of project in any kind of coding language. Boy, there will be lots of bugs. It's pretty unavoidable. And so learning to handle them is really important. And a big part of that, it isn't just that we're talking about, you know, technical mastery. We're talking about mindset. You know, this is really about that growth mindset. Yeah, something bad happened. Oh, well. Something isn't working. Oh, well. We're going to work through it. And that's what we really want to develop with bug hunting, is it's about that resilience, that confidence, and eventually the deep understanding. I mean, it doesn't come instantly, but as long as you're resilient, as long as you keep going, you keep trying, you get to that deep understanding. And actually, bugs often help reveal how things really work. And they challenge us to really think about what we're doing and what we want and how it works. So deep understanding really does come from bug hunting. And so a lot of the time our sort of natural instinct about bug hunting is, you know, oh my God, that's horrible. We don't want it to happen. We want to avoid it. No, it's part of the process. It's part of learning to code. It's a really huge part of learning to code and a really important part. So we want to engage with bug hunting. We don't have to fear it, even though it is things going wrong. Oh, well, you know, it's the fact that we can get through it. You know, we get, we stand back up, we dust ourselves off, we keep going. And that's how we're going to really be able to achieve whatever it is we want, whether it's in coding or anything else in life. As long as we can keep going, there will be setbacks. We're going to move through them. So how do we develop those skills, that resilience? Bug hunting is the way we do it. And whether it comes up because it's unavoidable or we even plan to include it, you know, we're going to do bug hunting. So let's dive into it. So for today, I'm actually daring to allow you to submit buggy projects. I would love to have you submit some projects for me to look at. So I've got a link to a Scratch Studio. You can go there through that link. Hopefully we can post that in the chat. Go to that Scratch Studio. You can add your own projects that you're having trouble with. If something's going wrong, add them to the studio, and then we'll all get to see them. And yes, we're sharing our mistakes. That may not feel entirely comfortable, but again, this is how we learn. And so you can see I've already created a number of projects in that Scratch Studio that have problems. And there's a buggy version, and I've made a fixed version of the project as well. So you can compare if you want to. You can look at the buggy version, try to fix it yourself. If you can't figure anything out, or you know something's avoiding you, you can take a look at the fixed version, and hopefully you can see the difference. And more importantly, hopefully you can try to process through and understand the difference. And that's where we really start understanding how the code works and how to solve problems or avoid them in the first place. Now, I also have a Padlet up there, so you can share through the Padlet as well. Either one works. I just noticed today, loading it up, I guess some automatic content checking process in the Padlet decided one of my projects was inappropriate. Now you can actually see in the Scratch Studio, you can see what the images are. So apparently it just interpreted the scribbles as something, who knows what, but you can access all of the projects there. So who knows what it's thinking, but yeah, talk about bugs, right? Things just go wrong. So yeah, hopefully you can share some projects if you have any where you've got a bug and have problems, and hopefully I can take a look at some, and we'll see what I can come up with for solutions. Now, of course, it might take you a little while to figure things out. So I've also included a little warm-up exercise project here. So it's a very, very simple little project that I've used a lot as sort of a coding introduction. So what we can do is I'll just hop over into that project. So you can follow through the links through Scratch. So if we switch over to my screen share, you're going to see our little bugged dinosaur basketball project. And speaking of bugs, you'll notice that for some reason the image is upside down. No idea why that's happening, but something on the Scratch website decided to flip my image. Who knows? Things going wrong is definitely the theme today. But if we open up our project, we're going to go see inside, and let's take a look at our project. So first thing we're going to do is we're just going to try play it, right? So we see what's happening. We see if we can spot anything going wrong, try and understand the project. That's sort of our starter, right? So we'll click the green flag, and we have a couple dinosaurs running around the screen, so I can control the green T-Rex here, and the red Triceratops is sort of computer controlled. And you can see there's a little timer and there's a score. And every time you catch the ball, your score goes up. So Triceratops is definitely in the lead. Hopefully I can catch up, but I'm not doing a very good job of catching up. I only ever seem to have 1 point. So that's definitely going to make it hard to win this game. So, okay, I think I have discovered the problem. Whenever I'm catching the ball, I don't seem to be getting a point, or at least I don't seem to be getting more than 1 point. So that's not ideal. So first thing we need to do is really understand what the project is. Then we need to see what's going wrong. And then we need to try and figure out why it's going wrong so that we can try and figure out how to fix it. So when we're bug hunting, there's a lot of different steps here that we have to go through. Now, when they're a really simple project and a really simple problem like this, it can be pretty obvious. Projects can definitely get a lot harder to figure out. So if you need to zoom in here, I can just start this up again. So when we catch the ball, the Triceratops is getting a point. When I'm doing it, I don't seem to get more than 1 point. So that's not good. So that's our project here. Sorry, I didn't zoom in the first time. So we've definitely got a problem here. And what we can do is we can think about, well, how is this happening? Who's involved, right? Sometimes your projects have lots of different sprites. Who's involved with this? Now, sometimes it's obvious, sometimes it's not obvious. Well, the Triceratops is basically doing what I expect it to. It's running around, catching the ball, getting points. The T-Rex, however, seems to have a problem. It'll catch the ball, but it doesn't seem to be getting the points. So when we think about all the different places we've got code, chances are the problem is with the player sprite, the T-Rex. So if we look at this, we can see that they've got a little bit of code here. I'll zoom in here so hopefully you folks can see it nicely. Fairly short little bit of code here. So when the green flag's clicked, score goes to 0. They start in a corner, point in a direction. They only flip left and right. Nothing wrong there. Forever goes towards the mouse pointer. Yep, definitely feel that. I'm controlling it. That's all seemingly working. How does it get points? Well, there's nothing in here that gets it points. Well, is that the problem? Or maybe because I get the points when I catch the basketball, maybe the code's in the basketball. So there's a lot more code here. And of course, we need to look through all of this. And as you can see, you start getting more code. It starts getting a lot harder to bug hunt because there's a lot more code to look through. Now, in this case, we know that it's when I'm catching the basketball. So can I figure out when I catch the basketball in my code? Well, in the left-hand code, we've got a timer. It counts down. We've got a comparison of computers and player score. None of those are actually giving you points. If we go over to the second column of code, we've got it starting in a position. Then we've got a forever loop. If touching player scored to 1, go to random position. Well, here we go. The player has caught the ball. And below that, we can see if the computer player catches the ball. Now, if we look closely, there's a really common problem here. some look-alike code blocks. They're the same colors, but they do different things. So up here, we have a set player score to 1. Down here, we've got a change score by 1. So this is why the player only ever gets 1 point. It sets their score to 1. So anytime they catch the ball, they go to 1 point. Doesn't matter if they've caught the ball 30 times, they go to 1 point. They go to 1 point one time, they go to 1 point the second time, the third time. They'll never have more than 1 point. That's our problem. So we can delete that block and replace it with a change score block. And now, of course, we have to make sure we're changing the right variable. So we want to change the player's score. And now if we play the game, I can zoom in here, we can see we're both increasing our points. And so there we go. Now we've got the T-Rex winning. So there we go. We've solved that problem. Maybe there's other problems, but at least we've made some progress. So that's an example of bug hunting. This was a very, very simple example of bug hunting, but we can see the process. So if we go back to our slides, we can take a look here. So that was our little warm-up exercise. Now we've got another more in-depth project that we can bounce to. But first, I'm just going to go through some of our concepts, how we actually go through the process of bug hunting. So my first step here was really sense making. The first thing we need to do is just understand what is happening. I played through the project so I can see what it's doing. Is there something obvious? Do sprites go missing? Are the numbers not counting right? Whatever it is, you need to see it in action. So we play through it, see what happens. Now, the second step is we have to understand what's supposed to happen. Now, this is really easy when you're actually just there in person with somebody creating something, because you can just talk it out, right? I want this project to have dinosaurs flying through space, shooting lasers, and saving hamsters, whatever it is. They need to know, what are we actually trying to do? You're going to compare that with what's actually happening and what you wanted to happen. And then you're going to be able to know, well, what isn't happening, or sometimes what's happening but shouldn't. So what can go wrong is just about everything. But we need to make sense of the project. So it's really about that looking through it, going through the process, seeing what's happening, what's not happening, what should happen, what shouldn't happen, and just identifying all of those things. Then we can move on to diagnosing the problem. And so like I did, I tried to identify what sprite might be the problem. Now, it could be multiple sprites. It could be how the sprites interact. But at least you want to go, I'm not having a problem with the Triceratops, get that off your plate. And it lets you start focusing in on certain areas because, all of that code in the project, well, if you can just read, one column of code, that makes it a lot simpler. So we're trying to narrow the field, who has the problem. We can then look at what properties are involved. So this is a term that doesn't get used a lot in Scratch, but gets used a lot in other coding. So a property is some statistic or choice that applies to a sprite. And that's really how we define sprites. So it could be the costume that the sprite is using. It could be the X position. It could be the direction, whatever it is. There's lots of different properties. And so we can think about what property is changing or not changing in order to try and, again, narrow down what we're thinking about. So is it a problem with how the sprite looks? Is it the wrong color? Is it not showing up? Oh, okay. That could be about visibility or the color being used to draw it. So, we could maybe narrow the field down to just the looks category. Okay, that's going to really help. If we just have to look for purple blocks, and that'll be something to do with the problem, then we can ignore, 90% of the other blocks, at least, to try and figure out, narrow down where we need to be focused and where we can try to change things. Of course, it's a lot harder if the problem is a block that's missing, because you can't see something that isn't there, but you can still know, oh, right, I should see a purple block here, and I don't. So there can still be that use to it. Lastly, you can also look at when something happens. So what kind of event or trigger happens that then starts things going wrong? Does it start as soon as the green flag is clicked, or does it happen only when you click on that character, or maybe you figure out, oh, it's only when this message is sent? Well, that means you can probably focus just on the code in that message event. So we can try and start narrowing the field, right, through diagnosing the problem. Then, of course, the real payout is hopefully solving the problem. Now, the goal is, of course, correcting the problem. There's an error in the code. There's something that could be fixed, and we add a block, we take a block out, we change a parameter, we change a property, whatever it is. Hopefully, we can solve the problem just outright, and there's a correct way to do it. Sometimes that works, like it did in the example. I changed a set code block over to a change code block. So that is a very direct change, very, tangible. Now it's correct. Sometimes that doesn't quite work. Sometimes, especially if you just sort of had the wrong idea of how to do something, there might be a different way to do it. And so you might need to come up with a different bit of code that you could write that'll achieve your goal, but in a totally different way. I should have come up with a good example of that. Sometimes when you start creating big projects, you'll realize, different ways that you could do something. Well, should you do this? Should you create a sprite to be doing that? Or could you do it with just a clone of a sprite that already exists? There's different techniques. There's different ways you could go about it, right? So sometimes you need just an alternate technique to do something. Maybe you realize, oh, if I do it as a clone, it's going to disappear every time I restart the project or something like that. And so, oh, that doesn't work in this case. Sometimes it would be the exact right thing to do. Sometimes it'll be the exact wrong thing to do. You got to just try it out. Things will change. The other consideration we have to solving a problem is to avoid having the problem happen in the first place. And so we can try and set up maybe like a protection system to avoid the problem. So in professional coding, sometimes this is called like error handling. So maybe if you're using like the ask block, maybe you're asking them something and it needs to be a number. Well, maybe you can take the answer and double check that it's a number before you allow the program to move on. And if it isn't a number, maybe you tell them, no, I need a better answer than that. You can ask again and tell them, hey, just a number, please. So there's ways that you can sort of avoid a problem from happening in the first place. So those are different ways that we can try and solve problems that do come up. So I haven't gotten, word of anybody having a particular problem here. I'll just double check, join back to the studio here just to see, but I don't see anything added in, but I could be dealing with an annoying delay or something as well. So what I will do is let's go back to the other example project here, and we're going to jump into the Scratch Race project. So again, a little weird to see because it's flipped upside down. So here we have a second buggy project we can take a look at. So again, I'm going to jump to see inside. We're going to see we've got a whole herd of scratch cats, and they're all prepared to race. So we're going to play through this, see what happens, and see if we can spot some errors, because there's at least one, and actually there's considerably more than one error to see in this project. So I'll hit space and let's see our scratch cats go to the races. So we've got our scratch cats running left to right, and things definitely don't seem quite right. That one scratch cat doesn't seem to stop running. And yeah, is that exactly what we were planning for? Well, probably not. Oh, and I hit the green flag, and now I get a win screen. Wow, things are definitely going wrong. So let's see this again. We'll hit the green flag. Okay, everybody's now colorized. Okay, let's hit space. Yeah, so we've got characters running along. That red one sort of is a little jerky. So, okay, number 2-1. And he slid over here for a nice little celebration. And we don't actually see them anymore. Well, that probably isn't right. So, the nice thing is, if anything is going wrong, I can just say that's part of the bugs that I programmed into this. But hopefully all of these were intentional. So let's take a look. The obvious thing to start with here is number 2-1, but they don't actually appear in the win here. So let's go over to Scratch Cat 2, because that's the obvious problem here. And Scratch Cat 2 seems to have won, but we can't see them. So if we go to this, there's a little win event when I receive player 2 wins. Okay, that makes sense. They get to say they won, and I believe there was a little word bubble there. They waited, and then they glide to the center of the screen, basically. And we got a little sound effect, which probably didn't share with you guys through the streaming, but you can believe me. But I can't see him. Now, there's nothing in here that would hide the character. So we have to get a little more creative. Now, we know this is about looks, right? We can't see the character, but we could see them slide over. So it wasn't that they disappeared. It isn't about a hide block, right? We saw that they slid underneath that white block with yellow outlines. So if they slid behind it, well, there's the layering system in Scratch, right? So things are in front of or behind each other. So what if we look for that? Well, we know that the order is a part of the looks blocks, right? We've got the, if we scroll down here, we've got the go to front or the go forward code blocks, and we can control what layer things are in. Well, we can actually see over in the when green flag clicked, there's a whole bunch of code blocks here. And here we go to back layer. that's going to be a problem, right? They're behind everything else. So there's a problem. Sometimes when you grab out a code block, it's set to the wrong thing, and you forget to switch it, or you click the wrong thing, easy little sort of typo type error. So if we change that to front, hopefully that's not going to be a problem anymore. Actually, I'll just pull a little code block out here. If we do set them to the front, they're actually visible over top. So that's probably the problem. There we go. So we can fix that one little aspect of the project that we saw was going wrong. So there's one of our errors. Now, part of the challenge with bug hunting is, when does a bug occur, right? Sometimes you've got this big project and the challenge is, oh, I know there's a problem in this one little section, this one little event, but it takes forever to get there. How do I actually make sure, if it takes me 5 minutes of playing through the animation before it gets to that error, it's going to take forever to test things and try new things and see the problem again. And so sometimes part of what you want to do when you're bug hunting is you want to try and make your life easier for bug hunting. So in this case, I've created a little cheat in the project to make sure it's easier for me to see, oh, we had a problem with number 2 winning, right? I want to see if I fixed it. But that means I have to play the game until player 2 wins again. That could take forever. If it's random, it could never happen again, right? I could hit the button, I could play the game, and everybody else just keeps winning, right? Eventually I might go, well, is that a bug? But what I can do is I can make it a little more likely. I can tilt the field. I can cheat a little and try and make sure number 2 wins. So what I've actually done here in the code is, you can see when the number 2 key is pressed, change X by 10. So essentially I can nudge player number 2 into a winning position if I just keep hitting the 2 button. So that's there to try and make sure that I can bug hunt easier, so that I'm not wasting all the time playing a race and playing a race and playing a race to try and get number 2 to win again. So if I hit the green flag, when I hit the space key, I can then bump number 2 up by just hitting the 2 button again a few times, get them in the lead, and then I make sure number 2 wins. And there we go. Look, number 2 is in the box. You can see them. We did actually solve the problem. So sometimes a real important part of bug hunting is to be able to, bend the rules a little, make life easier on yourself, right? There can be a need to do a lot of attempts or see it happen again to really understand it. So if you can try and jump ahead or something, sometimes if it's just a problem that happens when a particular message is received, well, remember, you can actually just click on a code stack to have it run, even if the project isn't really running anymore. So if I click, when I receive go, player 2 will start running again, even though the race has already been won. So you can call code and just execute it in isolation. You can try and create little cheat codes where you can press a button and bump somebody along. So there's ways that we can sort of make our life easier just to do, just to make our life easier as a bug hunter. So the way that you approach bug hunting can be quite different, and it very much varies on your project. This one I particularly designed so that it would be easier for us to deal with different cats and see what happens. So if we play this again, of course, number 2 is going to just keep winning now that I do that because I didn't put a negative button. But I guess now that I'm done, you know what? Actually, let's keep number 2 from winning. I'm going to make that a negative button so I can push player 2 back and make sure they don't win now that I've solved their problem. So again, there's ways that we can sort of cheat to help things. Now, something you might want to do if you are creating crazy little things like this just for bug hunting, you might want to add a comment because you don't really want this in the regular version of the project. So give yourself a note. Oh, right, take that out. Otherwise, people will be able to cheat in their race or something. Maybe you turn it into an actual button pressing race game. But sometimes really important to leave yourself hints to remind yourself of things like that. So let's try this again. I'm going to push 2 back. Let's see somebody else win. Okay, number 1 win. 1 goes to the center there. Perfect. Except they keep saying I win, and it's covering up the big title. Well, that's not ideal. So, okay, maybe let's fix that. When number 2 won, they said they won, but their bubble disappeared. Now, this bubble isn't disappearing. So if we go over to Scratchcat 1, we can take a look at our code. And again, we can think, well, when is the problem happening? Well, it's only happening when they've won. They seem to be racing about the same as everybody else. They got to the finish line. They were declared the winner. Everything else seemed okay. But it's just when they win here, we've got this bubble sticking around. And so when I receive player 1 wins, we can see our code. Say I win, wait 1 second, glide to the middle, sound effect. Right, that seems good. Aha. But we've got another one of those tricky, similar code blocks that are causing us trouble. So here we've got a say I win block, but it's not disappearing. Why is that? Because it's not a say I win for 2 seconds code block. Very easy to mistake those two, but one will automatically disappear after a certain amount of time. One just stays around until, well, forever. Or there's a second way that you can actually do it. You could say for a certain amount of time and then disappear automatically with a single code block. Or we could also just use a blank say block after a delay and it would disappear as well. So here you'll see I win and then it disappears because there's a 2 second delay, a 1 second delay here and a 1 second delay here. And then it says blank and the text bubble disappears after that. Now, of course, that's kind of a weird, awkward way to do it. It exists. It's not ideal. So I'm just going to switch it to the timed say block because why not use the block that does exactly what you want? So that's a great way to handle that. It's, again, a sign that I said earlier, before, that there are alternate ways to do things. In coding, there's almost always a different way to do it. there's so many ways you can do so many things. And so that's another example. If, for example, you didn't know how long you wanted that text block to stay up, then you wouldn't probably want to use a say for X seconds, right? Because you don't know how long you want it to be there. Well, then you could just say it and have it stay there forever and then have a blank say, remove it when you decide it's time to remove it. So maybe that system is the right answer for a different use case, right? So that's kind of the interesting thing about it. So we had a couple people, little mentioning about my book. Yes, Teacher's Guide to Scratch online course, I should say, has a discount right now. So there's a code there in the chat you can use. Please do take me up on the offer. There's a huge online course. It's 180 videos. It's something like 40 hours of instruction. It is everything you need to know to go from knowing nothing about Scratch all the way through complex ideas and concepts and all sorts of different projects. And we even get into some computer science terminology, which I've used a little bit here, as well as pedagogy, how to actually introduce these things into your classroom. So lots of opportunity there in the course to take a look at. There are also, again, the 3 books that I've published with Routledge. So thanks to the folks asking about that. I am slightly passionate about Scratch, as you can tell. If you write 700 pages about something, you might like it. So here's characters 1 and 2. We've gone through already in this project. We found 1 bug each. You might have suspicions about the other 3 characters at this point. So let's add a negative bump to player number 1. And now we can try the project again. And we'll bump players 1 and 2 back to make sure somebody else wins. And we'll see if we can get something else to go horribly wrong. So let's kick these 2 back. Okay, who wins now? Okay, it says player, I think, 3. So we've got our blue cat. Now he's just standing in an empty field. So there was a happy little sound effect. Again, that probably didn't come through with streaming. But we definitely seem to have a problem with number 3 here. We're not seeing our happy little win sign show up when the blue player won. Okay, well, we go over to blue number 3 cat here. What the heck's going wrong? Well, we know that there's the win event is what triggers everything. So we can look at our win code here and we see, say I win for 2 seconds. So we just discovered that's the correct way to handle that. We've got it waiting. We've got it gliding to the center. It's in the right position. There was a sound effect. Okay, so that's all fine. But of course, wait, the sign isn't a part of the Scratch Cat. There's a different sprite for that. So let's go take a look at the sign. So here we've got our code for our little win sign. And so, yeah, it gets the message. When player 3 wins, switch to costume 3 wins. Sounds about right. Let's go take a look. Costume 3, 3 wins, same box. It's the same as 2 and 1. Should be fine. The graphics are all right. So what's the problem? Well, here we need to compare. It's not a problem within itself, right? The code's there. We need to look at what's happening with the other events. Now, if we look over at when player 1 won, well, here's an obvious problem. When player 3 wins, there's only 1 code block. When player 1 wins, there's 2 code blocks. And a really important code block is missing. The show code block. Show and hide really easily get you into trouble with how things look. If something's invisible, it's probably not going to look right. So what we're missing is a show block. So let's just grab that little show block, throw it on the end here. And now, if we go back to 3 here, we've still got our little cheaty, sneaky code here to bump player 3 forward. So we can try and force player 3 to win. So we'll hit the green flag, we'll start the race, and we'll bump player 3 to make sure they win. And there we go. Now they've won, and the sign shows up. And they center themselves, and everybody's happy. So That was it. It was just a missing show block. Now that seems really simple. I would say that is one of the most common problems I have in Scratch. Even when I'm creating a project, I know if you hide something, you have to show it if it's ever going to come back. I forget that all the time. I'll use hide after, okay, they win the race or whatever, something needs to hide. And then I always forget to add a show block to when green flag clicked so that it's there in the beginning. That is absolutely the most common problem that I still make. Super easy. It's just something you forget about, you know? So show and hide, super easy to get forgotten. And so there's a little example. This one's a little more specific than my usual, just forgetting to put a show back when I've hidden something. So looks like we've solved player 3. We can turn their bump into a bump back and see if we can get 4 and 5 to win a race. So let's bump 4. Oh, what the? Well, that wasn't right. I was bumping 4 a whole bunch, and things didn't seem to go right. So we'll do that again, and 4 seems to be crawling up the line rather than moving towards the finish line. So clearly some problems there. If we go over to Scratch Cat number 4, we take a look here. We've got our when 4 key pressed. Guess what? I did change Y instead of change X. So again, an enormously common problem, especially when you're working with younger students that haven't necessarily done a lot of XY coordinate work. What does one mean or the other? You're going to get a lot of problems viewing between X and Y. So all we have to do is just switch that Y and X. And now we can cheat. So, well, maybe that wasn't entirely the biggest problem in the world that we couldn't cheat, but we can try bump 4 forward here. And there's still a big problem. So 4 won that race, but now it's saying 3 won. So that's not good. So here I have in Scratch Cat 4, we've got a when I receive 4 wins, I win, wait, glide, play sound. But 3 tried to claim the race was theirs, even though they didn't win. Well, let's go take a look at the sign, because we can see that it's displaying the wrong thing. And here, if we go to 4 wins, it says show costume 4. But costume 4 is 3 wins, and costume 5 is 4 wins because there's the start. So that is a tricky little problem. But is that a problem? And 4 wins. Switch to 4. It's using the name, so it isn't using the number of the costume. So this is kind of confusing. This is sort of an indexing problem. So costume 4 is 3 wins, and it's called 3 wins. Costume 5 is 4 wins and called 4 wins. So it's actually not that. It can trip you up a little. So if it's not the sign and it's not the cat, well, what is it? It's the line. If we go take a look at the line, we can see if touching orange 1, then 1 wins. If touching 2, 2 wins. Touching 3, 3 wins. If touching 4, 3 wins. It just got set to the wrong message. So when player 4 won, it shouted out, hey, everybody, 3 won. So definitely a problem there, but a very easy solution. So here, just the wrong message was sent. And again, it's really easy to have happen, and also to not notice, because you're just grabbing something off of a list, you know, 1 pixel away, and you get the right one, right? So just a little miss on your keyboard or on your mouse, on your touchpad, on a school computer, very easy to have happen. So that's definitely something that you'll see a lot in classrooms with kids that are still learning some motor skills. It's really easy for them to just select the wrong thing in those drop downs. So this is one of those really common problems that'll happen. But you notice we had to look in like 3 different places to try and find it. And so that's part of the problem with bug hunting. Boy, it might not be what you think it is. And it might not even be the second thing you think it is. It might not be the third thing you think it is. Sometimes it will take a few tries before you can really chase it down. But the way we solve it is we're going through a process, and we're going through the logic, and we're going, oh, is it how the player moves? Is it how when they reach the finish line? Is it the wind display? Is it, you know, the costumes being used? We can go through a list and we can check off boxes. You know, we can say it is or isn't this thing. And so, you know, you can make progress. And if you think about it in that more structured way, it can be a little easier to put up with bug hunting, because you can make sense that you are making progress, that there is this linear progression to be made, that even if you're not finding an answer, you're not solving it with what you're doing right then, you're still making progress, right? You can see checking off those boxes, you're you know, filling up the progress bar. And so that can help build the resilience and you know, build up the capacity for bug hunting and for, you know, goal setting and achievement. And so again, this is a really important thing that we can teach our students, and one of the reasons we really want to do bug hunting in our classrooms. So we're almost up. We've got 5 minutes left. I'm not going to finish the last sprite here. You're going to have to try do that yourself. I'm going to jump back to my slides. There is a finished version with everything corrected. If you can't figure it out yourself, the Bug Studio does have a fixed version, so you will be able to see exactly what's going wrong. But I challenge you to try and find it yourself. You'll notice there is another project in there as well. So that was our scratch race. There is Scribble War. I haven't touched that at all, but I do recommend you give it a try. It's definitely a more advanced project. But if I skip ahead, we've talked about that already. Bug hunting is something we really want to do. As Maren mentioned, you know, they have been including more concepts about dealing with debugging or bug hunting in Scratch, and that's been great to see. We want to engage with bug hunting. We don't want to try, avoid it, and fear it. It is useful and important. So bug hunting is professional development. It's something that you want to practice and do and engage with, so that you're learning and engaging and able to do it and not afraid of it, and you're able to help your students do it, and you can teach your students how to do it, because it is such a fundamental need if you're going to do coding. Bugs are going to happen. So it helps you overcome challenges, helps you learn how to solve those problems so you can help students. It helps you understand how Scratch works. It's going to help you teach your students how to do it. And importantly, if you are a teacher, you want to be able to create your own Scratch projects. And if you're creating your own stuff from scratch, boy, there's definitely going to be bugs. So you want to make sure you can solve those problems so that you can create your own Scratch projects. But furthermore, we want to teach bug hunting to our students. We want to use it as a lesson. And that's why I created that studio. Here's some example projects that you're going to be able to copy to your own studios, save a copy of the buggy version and give that to your students and challenge them to try and solve those problems. And thankfully, I've created the answer key in the fixed projects. You don't want to save or share that studio with your students because then they'll have the answers immediately. But if you make your own copies of the projects, you can then use them in the classroom, help build your students' resilience and their confidence. It's a great way to engage in social and peer learning because they can talk about the problems, talk about the potential solutions, what they see, etc. Help build up those critical thinking skills. And then when bugs do come up, you've dealt with them. You've dealt directly with bug hunting. You've laser focused. This is a thing we do. And then when problems do come up, when they are creating their own projects, when they're using Scratch for assignments and stuff, when problems come up, they know the process. We've been through this. We can talk about it. We can understand the challenge. We can overcome that setback. And so we turn those problems into learning moments. And so that's a super important thing to do. So thank you so much for coming to my session. Like I mentioned now a couple times here, the Teacher's Guide to Scratch. We've got the 3 different books that I published about it. So beginners, intermediate, and advanced. Wherever you are in your Scratch learning path, I've got resources to help you take you through the full thing as needed. There's support there for you however I can. You can reach out to me. Massive Learning, my company, also does teacher training and in-classroom workshops with Scratch. So you can always grab us. So lots of opportunities to learn bug debugging, bug hunting, super important topic. You want to engage with it. There's such a cool thing to do. And so, yeah, engage with it. Think of doing bug hunting. The problems aren't problems. The problems are opportunities when it comes to bugs in Scratch. So thank you so much for joining. I believe they're about to get the hook out to pull me off stage. Hopefully you enjoyed this. I'd love to see more of your buggy projects. If you come across anything that's stumping you, throw it in the studio. I'll try to keep an eye on it and try to come up with some solutions for people as I can. And of course, we can share with each other so we all have more learning resources around bug hunting and teaching our kids these important skills with debugging. So I think